Okay, so this one is for those of you who are struggling with area under the curve. We're doing area of a rectangle right now. And so what I have up here is a position time graph, and it's 2 segments. And I kind of made it sort of qualitative, not completely, but you can see that I have a positive slope and a negative one. And let's just pretend that when I calculate those out, I get a positive 2 meters per second on my first segment, and on my second segment I get a negative 3 meters per second there. And so I need to take that information, this is what you guys have been doing for me, you've been taking that information and creating a velocity time graph with that. And so we're going to go ahead and plot that. So I can see that I'm traveling at 2 meters per second for 2 seconds of time. So I'm going to find my 2 meters per second on my velocity time graph here. And I'm going to plot that for my 2 seconds of time. And then I have my second segment here, which is a negative 3. So I'm going to find my negative 3. And it runs from the 2 second mark all the way to the 5 second mark. So a difference of 3 seconds right here that it's traveling between that 2 second mark, which would be here, all the way over to the 5 second mark there. And again, we're going to put the little dashed lines just to help us visually connect the 2 pieces. And what we've been learning is about area under the curve. The area under the curve number 1 that I had you guys do, you kind of shaded in that area. I asked you what shape it was, and you said, oh, it's a rectangle. And you guys know that the area of a rectangle is the height multiplied by the base. And so you were able to calculate out what we now know as the displacement. So I look at my height. My height is a positive 2 meters per second times my base, which is 2 seconds of time. I cancel my seconds out, and 2 times 2 is going to give me an answer of 4 meters. So the area inside that rectangle is a positive 4 meters. Now what I'm noticing you guys doing that is a very common mistake is that when you shade in your area under the curve, you're shading it like all the way down to the very bottom of your paper. You want to stop at 0. So make sure you're stopping at 0. So the same thing would apply for a negative area as well. So when I say shade the area under the curve, we're going to start at that 0 mark, and we're only going to shade in the area down to the line that we made. And again, this area of our rectangle is the height times the base. So when I look at my height, I start at the 0, and I can see that I am at a negative 3 meters per second, and I'm going to multiply that by my base. Well, my base starts here at the 2 second mark, and it ends there at the 5. So I'm actually covering just 3 seconds. So that would be 3 seconds of time. Again, I cancel my seconds, and it's going to leave me with a negative 6 meters as my displacement. So my area is a negative 6 meters. But what I want to show you is that when we look at this area, we're saying height times base. So if I look at area of a rectangle and we're saying height multiplied by my base, well, we figured out that the area is actually the displacement. So I can kind of replace this with the displacement of that rectangle is my height. Well, actually my y-axis, which is my height, has a name, and that would be velocity. And my base actually has a name, and it's time. So if I were to come over here and take our velocity formula that we've been working with all along, which is velocity is the displacement divided by my change in my time, and I simply rearrange that formula, watch what happens. I'm going to multiply both sides by my delta t, they cancel on that side, and look at what I'm left with. I'm left with delta x is equal to velocity times my delta t. What? Which is the area, which is height, times my base. They mean the same thing. They mean the same thing. And we can apply this idea to any shape. We could use triangles, trapezoids. If I really wanted to be mean, we could do circles, but I won't. So we'll hold that space there on the different shapes because we're getting there next. But I wanted you guys to see this so that you understand some of the misconceptions that you're making. And I also wanted to derive how these are connected to what we've been doing all along. Hope you guys are having a wonderful quarantine time. I don't know what day it is, and I'm not sure how many days ago I brushed my teeth, but hey, we're still learning. Bye.